Hello, so today we'll start physics. No, we'll just do physics. Physics is we're doing waves today. Waves. Okay. Let's just start with questions. Questions. First question. A radio announcer reminds listeners that the station he works for is broadcasting at 720 kilohertz. How you say it? Okay. But what is the wavelength of the transmission? So first we have the hertz, which is the frequency. It says radio announcers, so we assume it's using radio waves. Radio waves travel with the speed of sound. We have velocity, and with velocity is asking wavelength. So that's just the v equals f frequency and wavelength. That's wavelength. Yeah, we have velocity. We have frequency. So we have speed of light is 3 times 10 to the power of 8 equals frequency is 720, but it's kilohertz, so 3 times lambda, the lambda should just equal to, where's my calculator? Okay, you know what? You know, I'm wrong. We need a calculator. Yeah, I got my calculator. Okay, calculator. So we just do 3 times 10 to the power of 8 divided by 720 times 10 to the power of 3. We get, oh, forgot to do brackets. We get 416.67 around. It's like 6 recurring, but like recurring. But we don't care. That's just, and lambda is wavelength. Wavelength is in meters. Yeah. And now we go to question 2. Question 2 says a park has a circular fence around it. The top of the rail of the fence is a metal pipe. A physics teacher sets a group of students the task of finding the radius of the fence by using their knowledge of sound. One member of the group hits the pipe with a hammer, giving a sound of 350 hertz. A second student, standing directly opposite the other side of the park, detects two sounds, 0.3 seconds apart. The speed of sound is 330 meters per second in the air and one sound is 310 meters per second in the metal pipe. Calculate the radius of the fence. Okay. Let's say that's the fence. Yeah. So we have student 1. So student 1 is here. He hits the it's gone. Okay. He hits the pipe, and then student 2 here detects two sounds. So the sound can come from directly from air, right? Can also go through the pipe. And so let's calculate. And this means that the 350 hertz doesn't really matter because it's just time. It's time, velocity, and distance because we're finding the distance. So this means we can just use the v equals distance over time, which equals for the air velocity, which is here, it says 330. V equals s over t. Well, 330 equals, well, in the air it should be 2 radius because there's 2 radiuses here. 2 radius over time. Okay, so time is 0.3 meters apart. Yeah, so the air will obviously take less time. Well, actually, because through the metal pipe is 1,000 meters per second, it's almost 3 times the speed of that sound in the air. So the metal pipe should, like, the sound from the metal pipe should like come like faster. So that means the air will take longer. If the air takes longer, the difference is 0.3 meters seconds apart. Yeah, so it will take longer because it travels slower in the air. So it should be time plus, let's do time plus 0.3. because it takes longer. And through the pipe, yeah, with pipe. But still velocity equals distance over time. So velocity is 1,310 equals, well, this here is just the circumference divided by 2. The circumference is 2r pi. Divided by 2 is just r pi. So r pi equal over, let's just set it as t. Let's not do t because we have t here. So just gonna do x, yeah. Do x. So that's that. So we want to find the radius and not x, because x is time. We don't really care about that because it's asking us to calculate the radius. So we'll just make the subject x. Yeah, we'll just move it down. We'll make the subject x. So that means this becomes x equals 330 over, you move that, no, you move this over here. Wait, so these two can swap, so then it'll be still 2r over 330, and it'll take 0.3, yeah. Yes, I think. Yep. 0.3. Wait, is that right? Well, actually, we should rearrange it, actually, yeah. So it'll be 2r equals 330x plus 330 times 0.3. That's 99. That means x equals 2r over 330 plus 99. Wait, it'll be take 99 over 330. Okay, that's good. And then now we're going to rearrange x here. So that means x equals just r pi over 1310. Then we can equate these two equations, and then we get 2r 330 minus 99 330 equals r pi 1310. And then we can move the r, yeah, so we can put r on the same side. So 2r over 330, actually we can take r out, yeah, be easier. So 2 over 330, this moves over here, this one moves over here, will become negative, so minus pi over 1310, because you took r out, and that should equal to 99 over 330, and then we just divide that on that side. So we'll first figure out what it is first, yeah. So 2 over 330 minus pi over 1310, and it equals some number. Okay, so equals some number. We'll just divide it straight away because the calculator is stupid, and then we'll do 99 over 330 divided by answer, and we get that r equals 81.91. And because it's physics, we round to 3, so 81.9. It'll be in meters because the radius is in meters. Yep, that seems fine. And then we'll do our next question. So the next question says, if you throw a stone into a still pond, ripples radiate out from where the stone enters the water. A group decides to take some measurements and record the following data to calculate the wavelength, speed, and frequency of the ripples. Some 5 seconds after the stone entered the water. So the time is 5 seconds. Enter the water, they noted that 42 ripples. Ripples means how many maximums of the wave there are. So that means, and then a wave, like a wavelength. So there's so then from maximum to maximum, is actually just a wave, because you just keep repeating maximum to maximum to get the full wave. So it's 42 waves, yeah? And then cover the distance of 2 meters. So distance is 2 meters from where the stone entered the water. Calculate the wavelength. So for the wavelength is the distance of the wave. So we know that there's 42 waves in 2 meters. So the wavelength will equal to, the wavelength should equal to 2 divided by 42, which equals to 2 divided by 42. A weird number. So it's just 1 over 21 and equals 0.04676 meters. And B, it asks us for the speed. So velocity equals distance over time. So equals 2 over 5. That's literally it. Equals 0.4 meters per second. And for part C, we want to find the frequency of the ripple or the waves. So for C, we want to find the frequency. So because V equals F lambda, then that means frequency equals V over lambda. And that equals to, well, 0.4. We already found out what they are. We'll do 1 over 21. And that should equal to 0.4 divided by that. 8.4 hertz. And that's it for the questions. Alright, bye bye. I did a video like late. I should have done it like yesterday, but I forgot because there's exams. Yeah, alright, bye bye.